6,000 CPM because that is the speed that it was calibrated at. So, but for your testing, choose the running speed of the machine. Okay, we'll change speeds in a moment. Let's start at 6,000 just to make sure it's okay. So increase the speed to 6,000. Go. And now press amplitude until you see inches per second RMS. And I'll do this in microns in just a moment. Or in millimeters per second. Excellent. Now lower the value to 1. Excellent. So this sensor is 100 millivolts per inch per second, right? It's a nice round number. And if I want to know, so when it was originally calibrated, it was 100 millivolts per inch per second, right? If I want to know what the sensitivity is now, I just need to set the amplitude to 1 inch per second and look at the screen in RMS and look at the screen, and I can see it's 110. So it is a bit high, right?
100.
Okay?
Yeah. Tapi ini 100 sama 100 milivolt sama tadi. Tadi boleh 100 sama tadi 4.
Not every sensor has the sensitivity on the side.
Milivolt. 100 volt per inch per second. 100 milivolt per inch per second. 100 milivolt per inch per second. Sama ya?
Okay. Now, does anyone know why we want to shake in inches per second or millimeters per second RMS instead of peak? That's a tough question. So by shaking in RMS, we don't have to do any math, which is nice. No one likes doing math. The voltmeter reads in volts RMS. So if you shake in vibration RMS, there's no conversions that have to be made when you're checking the sensitivity of the sensor that you're testing. Ideally, this sensor should be exactly 100, a nice round number. Now let's check it in millimeters per second RMS. So if you press amplitude, that is meters per second squared, so a couple more clicks. Okay. Now we're shaking at, what is it, 25? Okay. So this is a little more difficult in metric. It's always more difficult in metric because the sensors are made sometimes in the USA and the numbers are easier in imperial units. But the sensor is supposed to be 4 millivolts per millimeter per second, and we're shaking at 25, so we should be getting 100, right? But still, we're getting the same value. It's too high. If you lower the vibration to 25 exactly, that's pretty good. Pretty good. So we're within tolerance here, because anything from 90 to 110 would pass. So you understand where this number comes from? It's 4 millimeters, the sensitivity is 4 millimeters per second, 4 millivolts per millimeter per second, sorry, RMS, right? And we're shaking at 25. So 4 times 25 should be 100, right? So we're a little high. Another way to do it is pick a round number. Pick 10 millimeters per second RMS. So if we shake at 10 millimeters per second RMS, and our sensor is 4 millivolts per millimeter per second, how many millivolts? 40, exactly. 40, yes. Good? Okay. So the manufacturers don't make it easy on you when you test in metric, because you want to shake at 1 millimeter per second RMS, right? Because that way you wouldn't have to do any math. The sensor's 4 millimeters per second, and if I shake it 1 millimeter per second, I should see 4 millivolts on the screen, right? But 1 millimeter per second is tiny. It's this tiny amount of vibration, and it's really hard to measure, especially if the table's moving around or you're in a place with more vibration, right? In fact, if I bang on the table, this number goes up, right? So it's difficult when you're shaking at such a low vibration level. So it's always easier to shake at 10 or even 100. You could shake at 100 millimeters per second RMS, and if you shook at 100 and the sensitivity is 4, what voltage should we have on the screen? What number?
I'm going to state the obvious and say
I think I heard
400.
I think I heard it.
Did they? Good.
I heard 400, right?
Don't need to be shy, just say it so you
Yeah.
can hear it.
So you just have to multiply the sensitivity of the ProVibe sensor by the value in millimeters per second RMS that you're shaking, and this is the target voltage reading, right? Now you wouldn't really even need the voltmeter unless the measurement was wrong, right? If what's vibration shutdown level on the ProVibe sensors? How much vibration? We shut down the turbine at 250 mils. Does anything shut down if the ProVibe sensors?
Fan eleven, yeah, eleven 7.1.
7.1?
We have 3 fan, but the limit different. One and the other fan.
7.1 millimeters per second?
Yes.
Okay. So you would want to test at 7.1 and see if the vibration alarm shuts down. In fact, let's do that. You know that thing that's in a bubble wrap? Let's break that out.